Today we're going to talk about an intro to graphing quadratics. In our first example, we are going to plot the following points, and then we're going to fill in the blanks to the right. So I'm graphing y equals x squared, and I have my table of values, which says -3, -2, -1, 0, 1, 2, and 3. We are squaring each of those values to get the column on the right here. So we're going to take a quick minute to plot our points. And once you have one side, it is the mirror image on the other side. And then we can connect our dots. It makes a U shape. It does not come to a point at the bottom. And we extend our lines with arrows on the end. That midpoint here at the base of the graph, we call it the vertex. And the axis of symmetry goes right through that vertex there. We use the axis of symmetry with a dashed line. So my axis of symmetry cuts through the vertex at x equals 0. That low point or minimum point is our vertex at 0, 0. We have an x-intercept at 0, 0. It only crosses the x-axis once. That is also our y-intercept for this particular graph. So again, our middle point in the table of values is going to be our vertex. On problem number 2, we're going to graph the following. It says identify the vertex and axis of symmetry again. We have blanks for the x's that we need to fill in, and the equation that we're graphing is x squared minus 2. In general, the forms of quadratic equations in vertex form, which is what we're doing, are y equals a times x minus h squared plus k. When I set the part that is squared equal to 0, that's going to give me what we're going to call our argument. So in this case, this x part right here, I'm going to put parentheses around it. That x is equal to 0, which is our first little number in our table of values. And again, we're going to call that the argument all year. And I'm going to do points on either side of it. So I have 1 and 2, -1 and -2. And we substitute those values into our formula every single time to find out where our shape is at. So I have -2 squared minus 2. I have a -1 squared minus 2. I have a 0 squared minus 2. I have a 1 squared minus 2. And I have a 2 squared minus 2. We're going to evaluate each of those points. I like to start in the middle with my vertex, so that I get a -2. I fill that in over here with 0, -2. And that also tells me my axis of symmetry is x equals 0. The x value of the vertex and the x value of the axis of symmetry should be the same. When I evaluate the other points here, I have 1 squared is 1 minus 2, gives me a -1. When I square the 2, I get 4, minus 2 more is 2. We get the mirror image on the other side over here. And we have our values. So we're going to plot. We come down 2. Again, it is the mirror image because the axis of symmetry cuts right through the graph. It creates a mirror, and I can plot my other points. It is a U-shaped. Extend, put your arrows. Third example, it says that we have y equals -x squared plus 4, very similar to the last one, except this negative right here is going to give us a reflection. So the graph is going to go upside down instead. Again, when I take that x and I set it equal to 0, I get a 0. And we're going to do 1 and 2, -1 and -2. Again, we're going to substitute them in to the formula. And then we're going to evaluate. So when I take the -2 and square it, I get 4. It makes it into a -4, which gives me a 0. I have a -1 squared, which is 1. Apply the negative. I get -1 plus the 4 gives me a 3. I have a positive 4 here. I have a 3, and I have a 0. So again, my vertex, the argument was 0. This is the vertex again. We list it. Our x equals 0 is our axis of symmetry, and we plot those points. So if the screen locked, is it still recording?
Ooh, I don't know. I think so.
Okay, great. Sorry for the technical difficulties. So we have our vertex plotted. We have our additional 4 points. Again, that negative in front of the x squared is making the reflection, which makes the graph turn upside down. On problem number 4, we have inserted some parentheses here, which really helps us with identifying the argument. Again, I'm going to take that part that's in the parentheses, the x plus 1, and I'm going to set it equal to 0 so that I can find out that the x value of my vertex is negative 1. We have 0 and 1, and we have negative 2 and negative 3 are the other values for our parabola. The y value of my vertex is that 2 that's right there. And again, this middle one is our vertex. Again, our axis of symmetry is the same as the x value of the vertex. And I'm going to start by plotting that point. So I have negative 1 and I'm going up 2. Besides substituting the values into the equation and doing the order of operations to get the y values, another way to look at graphing parabolas is to go out 1 unit. When you square it, you get a 1. Going out 2 units, you square it, you get 4. And you know that your axis of symmetry is right here, so that you know that you have another point on the other side, and your last point is the reflection. Again, if you substitute in negative 3, negative 2, 0, and 1, you will come up with these same points that I have plotted here. So when we substitute it in 0, it should come out as a 3. This one should come out as a 6. And we get the mirror image on the other side of that. On number 5 here, same idea as what we did up here. I'm going to take the argument, this x minus 3, set it equal to 0. I get that x is equal to 3 for my argument. Again, the y value is the vertex over there. This negative 2 is finishing off my vertex. And the axis of symmetry is at x equals 3. I use this point, so I count over 3, up 2. Again, it is a positive parabola, so I can go over 1 and up 1. I can go back to the vertex, out 2 and up 4. Mirror image on the other side of the axis of symmetry. Again, you can substitute those same values in and do your order of operations, 1 minus 3 and squaring it and subtracting 2. Oops. Scratch that. I should have gone down 3. Or down 2, so sorry. We go over 3 and we go down 2. There we go. There's our parabola. I missed that negative. Okay, so then these are at negative 1, and these ones are at 2. Okay. A second type of graphing parabolas is from the X-Intercepts, and so you're taking each of these, setting them equal to 0, like we did in the last unit when we were factoring and solving. So we get x equals 4 and x equals negative 2. We're going to write those as X-Intercepts. So I have 4, 0, and I have negative 2, 0. I'm going to plot those. I'm going to find the midpoint for my axis of symmetry. I'm going to count from both points to the middle, one in each direction. That puts our axis of symmetry right in the middle of those at x equals 1. That gives us a couple of things. That gives us our axis of symmetry is at 1, and the vertex value is also at 1. To find the other half of the vertex, I substitute it back into the original equation. So I have y is equal to 1 minus 4, and 1 plus 2 gives me a negative 3 and a positive 3, which gives me negative 9. That is the other half of my vertex value. So that's way down here. I can connect my dots. 3 points is enough to draw the parabola. We have the x-intercepts. We have the vertex. I could find the y-intercept by substituting in 0 for x. And so when I do that, I get 0 minus 4 and 0 plus 2, which gives me a negative 4 and a 2. That gives me a negative 8. There is my y-intercept. For the last one, it's not in factored form yet. I need to change it to factored form, so I take out the x. And I set each piece equal to 0. I'm going to add 4 on this side. So my x-intercepts, we have 0, 0, and we have 4, 0. This one is also our y-intercept there, 0, 0. It's crossing the x and y-axis at 0. Again, I need the midpoint of those, which is happening at 2. That's my axis of symmetry. So I can say that we have x equals 2. Vertex value is at 2. I need to figure out where the y value of the vertex is, so I'm going to substitute that in. We get y is equal to 2 times 2 minus 4. I get 2 times a negative 2, which gives me negative 4. Connect my dots, extend with arrows. There is my graph, again using the intercepts. We factored it, we set each piece equal to 0, started there, got the midpoint to get the axis of symmetry, substituted in that x value back into the formula. I used the factored form, giving me the y value of the vertex. These last 3 problems, or 4 problems, are the same as what we've been doing. We are trying to factor, so I'm going to start with number 9 here. I'm going to factor this. Gives me x plus 1 and x plus 1. Again, that's the same as x plus 1 squared. To find the x-intercepts, you're setting each piece equal to 0. In this case, it is just a single x-intercept at negative 1. We have negative 1, 0. Okay, so I have my x-intercept at negative 1. That happens to also be my vertex because this is now in vertex form here where we have x plus 1 squared. So that is the same as my vertex. It is also the same as my axis of symmetry. And to get some other points on the graph, I'm going to go out 1 and squared, I get 1 in both directions. I go out 2 and squared, I get 4. Go out in both directions. Extend with arrows, and my y-intercept was that additional point that we got right there. That is at 0, 1. So you're finding the x-intercepts on 8, 10, and 11 as well, and following the same steps.